Hey everyone, and welcome back to Seedcamp Firsts for our part 2 onto deep dive into A/B testing and good data science practice with Candice Wren. In this episode, we're going to go deep into a specific case study about how you set up a good A/B test experiment, look at the data, and make an informed decision on what you should do with your product. Candice, welcome back.
Hey, Devin, thank you so much for having me and good to be back.
Yeah. So obviously in the first episode, we went over a lot of the broad strokes of what A/B testing is, how you use good data science in making those decisions, and more so the cultural significance inside your startup and why you should think about this, and also when you should start doing it in a really concerted way. And so today, what we did is after that episode, we talked about maybe we should just go deeper into a specific use case where we can go step by step and talk about some concrete numbers. And so that's what we're going to do today. And so for those listening to the podcast, what we're basically going to do is we're going to look at a very common feature scenario where you're not really sure which one is the right one to do with. So in this case, it's with recommendation algorithms. So let me set the stage. You're running product at a medium-sized startup. You basically are a massive fashion marketplace. You help people find the perfect furniture for their home, right? This is a pretty common sort of offering now in the market. And what you're faced with is you have your traditional algorithmic recommendation engine. Maybe it's Algolia, maybe it's something like that, and it's doing an okay job. Now, there's these hot new startups, a little bit of LLM-powered AI machine learning stuff coming to play, saying that with our new LLM-powered full text search, full everything, we can provide a much more accurate recommendation to your users. So you're faced with the classic A and B. Is the current algorithm performing well for the users and also for your business needs? Or is this new thing going to do better? So Candice, you're faced with this problem. How do you approach, setting up the experiment to help you make the decision? Where should you invest your time and money?
Yeah, so that's a very classic case. Recommendation algorithms, I guess the first thing you think about is the goal, what we're trying to achieve here, and how we get there. So
Yeah.
in this classic case, we wanted to have a better recommendation. So the first thing to think about, how do we measure it? And with that, what we're going to do is test out these two, as you said, A and B.
Yeah.
So then you have to think about what do you test it on, how big a user group you're going to allocate to these two groups. So
hmm
typically you will have a control, you have a test, and then thinking about the users that are going to be faced with these two algorithms, and then
hmm
how to compare the results, how long we run this test for, all the interesting bits that comes with it.
Cool. So we have these two separate offerings. Let's call it algorithmic and the LLM powered one, or for simplicity, let's call it algorithmic and AI, just simple shorthands. So how do you get started? How do you set a hypothesis for this? Because I think that's one of those sort of subtle things. You can't just say which one's better, right? So what's the hypothesis? How do we build sort of the test case?
So it's good to be a bit more specific
hmm
towards the goal. So we want a better algorithm. What does that mean? And in this case, we could keep it simple to say, okay, you as a user, you were presented with some recommendations, let's say a sofa, and the algorithmic one recommended, let's say, a green sofa, and the other one recommended something based on your own taste, based on LLMs, perhaps search histories. And we can keep it simple to say, click down this recommendation. So they were interested in a recommendation, they explored further. So click-through rate is a really good one when you're
Okay.
facing this kind of situations. So, we have set the goal, and then the hypothesis will be if we change the algorithm, the click-through rate on the recommended so far will be higher.
Cool. And so how do you pick click-through rate? Because obviously when you're looking, say, this marketplace example, why not pick purchased or added to cart? Or why is it just going from that search result or those recommendation results through the first user action available? Why would that be the one we pick?
That is a perfect question. In the perfect scenario, you want to look at the whole flow. So if you think about what happens after you were presented with a recommendation, you first need to click on it, and then you decide a few things. You probably look around the text, you want to see the fabric, you want to see a few other things, the price, and then you decide whether you purchase or not. The reason we don't look immediately into purchase is because there's other factors at play. So it's not 100% determined by the algorithm. So there could be a lot of things. The product might be out of stock. It might be out of a price range. You could argue that a perfect algorithm should take into consideration all that, and you'll be right.
Yeah.
So the ideal scenario, you first look at CTR. So people need to first be interested in the suggestion, and then they will be able to purchase. So ideally, you will look at a range of metrics.
Right.
But to keep them test simple, you want to have one metric. And then while you are continuing the test, you keep an eye on the purchase rate. And
Cool.
there's also related questions like, do you have enough sample size to the purchase? Because there's a drop off, maybe 50% click on it. And out of that 50%, maybe 2% purchase. If you look at the end metric, it will be a long time until you get to the results.
And so in that, because this is, I think, one thing that I know I've struggled with when setting these things up is how granular you make the test. Because, in the perfect world, you're doing everything so people do transact on your marketplace, right, in this example. So you'd almost want to say that revenue or sales figures or full purchase flow is the North Star metric. But that's a difficult thing to track if there's like multiple touch points throughout the entire product to get there, right? So how do you know how granular you get? And do you have sort of a rule in mind when you think about setting these tests?
So if we step back a little bit, I guess what to test, there's a purchase flow and there's many touch points, like you said. And when you have a touch point, there's a potential drop-off point as well. So before you get into what to test, it's good to look at your conversion funnel. Let's say the flow is you get on the website, you type a search, you get recommended so far, you land on the recommendation, and then a few other clicks to purchase, right? So every step is good to have a look at your drop-off. If, for example, the drop-off at the recommendation stage is like 2% or nothing, then you don't need to test it. It's pretty good already. Everyone is clicking on it. So you don't even need to run this test and don't bother with the LLM because
That's
it's
a
not
great
going to
point.
be. Yeah. So, this is a thing. So we think about it as a flow, and every step, if you move it up a notch, so let's say you start with 100 people, they got a recommendation, they half click on it. So every step, your goal is to improve it. Right. So
Yeah.
it's at that step, improving it. And hopefully, if every step improves marginally, your purchase rate will be a lot higher. That's the idea.
Right. So if you view the classic funnel, it's like if every major motion to the product and those ratios stay the same, if you increase any part up the funnel's upstream, it should naturally, with some signal loss, increase across that funnel. So you can almost argue that you should almost always test like super granular to start and only expand the metric you're trying to capture if you're not seeing that sort of uplift across your funnel, right?
100%.
Got it.
And you should always start where the drop off is the largest.
Right.
Because that's where the biggest potential. And
Yep.
it's probably where you're doing the least well.
Yeah. Perfect. Okay. So we've picked our metric. We're going to test the click-through rate, right?
Mm.
So how do we start setting up our hypothesis or setting up the actual test framework for this experiment?
So for a test, you now have the background, what you're trying to do. You have the test metrics. Now is execution. So now you want to have two algorithms imposed on two group of users. So that's the
Okay.
next thing. Who gets what?
Right.
So that's what we like to call the user allocation. And at this point, you need to make sure they are randomized. So you don't introduce other factors that could influence your results. Ideally, you have a randomization algorithm that's picking users and allocating into two different buckets. So you have control, which is the current algorithm, and you have the test, which is this LLM model.
Yep.
That's the second bit, making sure these two groups of users are getting a two different algorithm and they are completely randomized. You need to decide on the split. So how many users you are allocating. So typically you do a 50-50, but really depending on the use case, sometimes you want to allocate just 10% to the test if you think there's a high risk. And yeah, so that's the second step.
And talk me through that, because I think this is one of those maybe non-obvious parts. Oh yeah, 50-50 split. Half the users go one way, half the users go the other way. What are some things you've seen from your own practice where you wanted to be more cautious in that division? Like just 10% see this feature set. What does that look like? And when should people be more aware of being more selective with that split?
So there's a few considerations that's wider than one test because we are talking about a test scenario, like a scenario that's out of a hypothetical company. But in reality, you might be running quite a lot of different tests, right? So your marketing department might be running a acquisition test. Your finance team might be running something else. Your billing team might be running a pricing test. And then that is where things get a bit more complicated because you don't want to overlap your test.
Right.
And so when we say 50-50 split, it's not necessarily 50-50 of your entire user base. Because when you get to a certain stage, you want to start reserving a group of users for different test cases. So that's one thing to consider. So you might be allocating 10% and 10% of your users into this test. Let's say you have a group of users, let's say is instead of half-half, what are some of the times you only put a small amount in there? This is where the risk of something that could be quite high. So if you're doing a pricing test, let's say a discount code of 20%, then you might want to only allocate a small amount of users just to make sure in case this test doesn't go well, it doesn't have a big negative effect on your existing revenue stream. But the other things to think about is if you only allocate a small percentages, then the sample size, would it be big enough? So it's not a clear science. There's so many factors to think about.
And is there and I think I know the answer to this, but is there sort of a school of thought where you just turn it on for everyone for a week and just compare the previous week and the current week? Can you do a time series based comparison, or does it always have to be in parallel?
So that's a really good question. Some company do. The thing is, the reason you do a control and test in the same time period is to eliminate other influential factors. So if you have a product that has a seasonality, for example, and you happen to switch on the test during Black Friday, and then you compare to the next week, then you don't have a like for like. So really A/B test is meant to be giving you an apple for apple situation. So you don't have to consider, last week, it's Christmas, everybody was out shopping. So that's one of the reasons. But there are other scenarios you have to do things this way. But maybe that's another episode.
Yeah. Okay. Great point. Okay. So let's say we've got a 50-50 split. So 200 users, 100 are going to the algorithmic, the classic recommendation module, and the other 100 are going to this new LLM powered recommendation algorithm. So what happens? I think you gave us some interesting test case numbers. You said in the results from your little test run, 20 went through on the algorithmic and 30 went through on the LLM. So 20% versus 30% click-through rate. What do we do with that? I know for me, it's, 30% is bigger. Success. But I'm guessing that's not as simple as that when you really try to approach it from a scientific perspective, right?
100%. So when you see an uplift, which is great, if you see a drop, then you probably don't need to do anything else, just switch it off. But if you see an increase, the second question is this increase good enough, right? And how do you define good enough? First of all, is lots of people talk about the statistical significance. So when you have something that's performing better, it could be just due to randomness. So when you have a small test case, let's say you only had one person in one group and one person in the other, and one clicked and one didn't. You have 100% versus 0. In this case, it doesn't mean the first group is better. Not necessarily. It could just be, it just happened that person so that's the whole thing about randomness. So it's noise that's being introduced into your test. So that is where you test for significance. Significance means with a certain level of confidence, the new algorithm is indeed better than the first one.
Okay, cool. And so we have this 20 to 30%. So which one do we pick? I mean, obviously 30 is bigger, but you present this to maybe your product manager, or maybe even if it's a small enough company, the president of the board being like, look, the new LLM's working. How do you discuss that in terms of confidence?
So it's good to put through a significant test. And luckily, we have a lot of algorithm that's pre-built for us out there. One of them, the chi-square one, which is typically used for if you have a conversion matrix. Conversion metric is a percentage metric. So you can just put it through the algorithm and it will tell you with a certain level of confidence interval, this test is indeed successful. This to prevent you when you roll it out, because it's a sample test, when you roll it out in your real market, the population, it is indeed what you are hoping for. And it's not due.
So we before this call, we plugged these numbers into a chi-square test, and 20% conversion rate results in a 13% to a 29% confidence interval. 30% click-through results in a 22%, a 40%-ish interval. What does that mean? What is a confidence interval, and how do I turn that into action?
So I think it's good to keep it simple without going into the details of the statistics, because first of all, you probably don't care, or wouldn't care. But the key thing is really, so the p-value. So this is where probably a lot of people would have heard of confidence levels, and some would accept a 95% confidence level. Some would accept 90%. So p-value is the 1 minus the confidence level. So most tests will produce you a p-value. And at p-value equals to 0.1, that you have a 90% confidence level. Typically, we will recommend 95%, but sometimes you might decide 90% is good enough as well, which is indeed the case for our sample test.
Cool. So in this case, even though with a confidence level of 95%, it's not super significantly different, but at 90% it is. So we could say we're pretty confident that sample 2, or in this case, the LLM, is performing better given this test.
Yeah, so this test at 90% confidence level, it is significant. At 95%, as in, if your standard is higher, it's not quite there.
Okay, makes sense. So we basically run the test. We've figured out after running through all the specific testing steps, we did a 50-50 split. We ran it on over 200 users. We at a confidence level 90%, it looks like it is statistically significantly better, the LLM. So what do we do with that? Do we just say LLM for everybody? Done. What happens?
So this is for a strategic discussion now. So at company level, you should have some testing guidelines, and also depending on a lot of other factors again. So if it's time to retire the old algorithm, you just wanted to make sure this has a positive effect, then go roll it out. But make sure when you roll it out, you still keep an eye on your numbers. Make sure you monitor the CTR going forward. There's a few other things to think about. Make sure you conclude this test. Say if you are only rolling the test to a percentage of your user base, make sure you switch it off so you don't have legacy code still there.
Yep.
But if 90% is what you're happy with, you can roll it out already.
Cool. All right, easy. And so that's a very tight test case of a relatively common thing. One thing that I was thinking about when we walked through it was something you mentioned, which is what happens if you have multiple tests or you have the desire to run multiple tests? How do you orchestrate that? What's the sort of framework we use to make sure we're not creating bad results for other tests because we're over-testing a different feature that doesn't actually map to the original hypothesis of the other feature? Like imagine, just off the top of my head, like we actually have a new payment flow on that page at the same time. Like we just introduced Apple Pay and Google Pay. The huge difference in maybe our old credit card system is that changing our click-through rates, how long people are dwelling on pages. How do you think about that in a larger and growing organization?
This happens every day. First of all, it's not an uncommon problem. So when you have different types of tests, so there's two different things. One, if you have a billing test, in your case, the pricing flow test, you have a different algorithm test. Here is a more A/B testing design. So what you want to ideally do is allocate reserve users for different departments. So let's say if you have 1 million users and 100,000 will be allocated for testing purposes for billing team and 100,000 for, let's say, website changes. What you want to do is not to introduce those scenarios. That's, the contamination of your test. So let's say you have 100 on old algorithm, 100 on new, and then a percentage of them, they are subjected to the new billing flow. And that percentage might be different between the two groups. So this is where you get this 4 combination going on.
Yeah.
And then you don't have the apple for apple scenario anymore. So make sure when you test, you are changing one thing at a time for the targeted groups.
So going back to that original point when we talked about thinking of the funnel as multiple steps and trying to optimize just that one little step, that's even a better reason to keep it granular is you're trying to build that tighter control in what could otherwise be a chaotic product, depending on what's happening.
100%. We've seen tests going on. A simple thing like a website, you changing 10 different things on the website. But then there might be 3 things that is good, 7 that is bad. When you get the result, you don't know which is which. So this is why you want to keep your tests very granular, like you said. And so you don't waste time thinking, okay, my test result is a bit weird. Can I trust it? Out of these 10 things have changed, what should I do? What should I not do? And then you have to do it again. So you may as well test one thing at a time.
Yeah, so very, very simple sort of guardrail, which is keep it as tight as possible, limit those variations, focus on a very, very well described hypothesis and nothing else. Look at that one thing. That makes a lot of sense.
The other thing just to speed things up as well, if you have 5 different things you want to change, you can have ABCDE test. So it doesn't have to be 2 groups.
Right. So you can just create, which is, I believe the term is multivariate testing, where you can do a lot of different stuff at once.
Exactly.
Yeah. And
But
obviously, there's
main
so many modern packages that help you actually collate that data anyway. The hardest part is off your shoulders if you're using those bits of SaaS or whatever.
Yeah. The key thing for you to determine is what to test.
Yeah.
And then the SaaS product can help you do the rest.
Cool. And one little sort of meta piece around this, what's the best way to store those results? Obviously, if it results in a product change, then it's a product, but I'm sure there's always those little bits of learning. How do you keep that into a playbook? What's your recommendation there?
So ideally, from a data perspective, all your A/B test results is automated.
Yeah.
So at any point in time, you can go in, you have a centralized dashboard that tell you a lot of things to say, hey, last quarter, we've run 100 tests out of these 5 departments, and these are the themes that we tested. These are the winning variant. And this is a summary, so you know what happened. So you can always go back and think about if you need to refer back. But at the back of that is good to document. The one key things we always recommend is don't test what you already know. So just a simple example, if you have a blue color theme versus a green color theme, you've tested it. Green is what works for your brand. Make sure no one else do this ever again. So
Yeah.
you should have a centralized location, your knowledge base out of your A/B testing to say, okay, this bunch of things we already know. This is what we know based on our customers, based on their taste, based on their affinity with our brand. This is what they mostly like. So those things, you have it. Equally, you have a list of things that don't work for us. So you have a centralized location, every team, maybe you have a new product manager coming on board. They should have a place to see all these things. So make sure you document those.
That makes sense. So we've run this test. We have the results here. One of the things we briefly mentioned in the beginning is then how does this impact the actual core business metrics, things like revenue or the purchase rate or whatever that North Star metric could be for this artificial marketplace we've invented. How do you start to bubble that critical information into these tests?
So far, we looked at the click-through rate only and with one chi-square test on top of this. So ideally, when you're designing your A/B testing dashboard, you should have a list of other metrics. So we always recommend a few, what we like to call counter metrics. We call it counter in the sense that there's no negative impact on these metrics.
Right.
Only there's a positive impact you should always aim for. So not just with CTR, you should have the CTR visibility, but at the same time, your test should also show you what is the revenue at the back of this test. So for the control group and the test group, following the click of this so far, what is the revenue numbers for each test?
That is a great point. Like this is something that we actually discovered by accident at my time at List was because we were a fashion marketplace is we introduced a bunch of new browsing tools for our users so they could create wish lists, get recommendations off that. And what we found was time on site went up, which is like great. But the purchase rate actually went down slightly because they were spending more time exploring and imagining rather than being like, oh, what did I need? It's a pair of shoes. There's the pair of shoes I need. Like we had changed their own internal motivation for being there. And ultimately, in the end, we figured out how to make it work, but we just didn't even consider it was going to hurt our revenue. We didn't even think about it.
100%. That's why you should always have that visibility really easily. So every single test, let's say you're a product manager, you should be able to have those visibility on the longer term impact of the business.
Do you ever find it difficult to correlate sometimes these smaller changes? Obviously, changing your recommendation algorithm is significant, but then there's a couple leaps to get to the revenue or the purchase rate or the basket rate or whatever it is. How do you build these somewhat tenuous connections? How do you draw a correlation between, oh, it was this that might have actually had the impact?
So we kept it simple purposely for this podcast, but in a real company scenario, you will have more than just these 2 numbers with your A/B test. So back in the days, we will have a really robust A/B test dashboard with a whole bunch of metrics. And you can select the ones that is related to your particular test. So in this case, we'll have the CTR on the so far, and then we'll probably have a list of other metrics, for example, the time on site, or the time on this so far page, maybe abandonment rate of this basket, like all this then give you a bigger picture. So it's not just this click and then the last step, which is purchase.
Yeah.
So ideally, you should have data visibility every step through the customer conversion journey. And then you will be able to connect all the dots easily within one dashboard. So you have the 2 groups, you have the CTR, you have the significance of these 2 CTR, and then you have a whole bunch of metrics to say, the percentage conversion to the next step, the revenue figures, percentage purchased. You should have a whole list of metrics relating to what you're testing.
Well, great, Candice. That was a fantastic overview of a really tight case study on running an end-to-end A/B test, right? Like we covered how you set your hypothesis, what is the best way to segment your user basis and why, how do you pick what you're actually controlling for, in this case, click-through rate, and then also talking about how that can bubble up into more major product decisions and maybe even affect metrics that you didn't already consider, some side effects, and then how you work with that. So I think we've hit every point. So thank you so much for taking the time. I'm translating that higher level knowledge into something very tight and concrete that we can deploy today in our companies.
Thank you so much, Devin. I really enjoyed our conversation, like always.
Yeah, always.
Thanks for having me.
Yeah. Well, thank you very much, and hopefully talk to you soon.
Sounds great. Thank you,
Bye.
Devin. Talk later.